we were just about to knock out the denominators, okay? But technically what we're doing when we knock out the denominators in an equation is we're making them common, and then we're canceling them all out because we're doing it on both sides. But you can only do it if they're common, because technically you're multiplying all by the common denominator. So it's easier just to say, what would the 10 need to multiply by? Well, a 6. So that would get rid of that denominator, but this will need to multiply by a 6 wherever you want to stick it. Okay? What about the 12? What would the 12 have to multiply by to become a 60? So that x will be times 5. And on the whole number, there's no denominator to knock out, so it needs to actually multiply times the 60. So distributing, you have a 30 plus a 6x plus a 5x equals what? 60. And so then combining, you got 11x equals what? Okay, which doesn't divide nicely, right? So I would take 30 over 11, but really this is a real world application, and you don't want to tell people that, oh, and by the way, let's double check, does X answer the question? The question is, how long will it take to fill the pond after the second pipe is open? So we don't need to include the 5 hours from before it, right? So X is how long the second pipe was open, so that truly is our answer. So 30/11 hours, yeah, I'd take it, but it would be better to either write it as a mixed number. So how many times would 11 go into 30? How much would be left over? 13. What's 2 times 11? 22. Oh, 8. Yeah, and 8/11 left over. And of course, it'd need hours. Or you could just do 30 divided by 11 in the calculator, which would be 2.727 hours. Yeah, go into the Stewart Standard there. I would take any of those because they didn't give you a hint of what they wanted the answer to look like. All right? Now, we take it again. We're going to throw another little interesting thing into this mix. Okay? So this time the story is Ronaldo. He's filling his pool. So I'm kind of picturing this inlet pipe. Maybe he has an in-ground pool that has an inlet pipe. Me, the only pools I've ever had in my yard were standing above the ground. And the inlet pipe was a garden hose flung over the edge. All right? So however the water's getting in, there's water coming into Ronaldo's pool, okay, in 5 hours. And at the same time, an outlet pipe can empty it in 8 hours. Well, Ronaldo forgets and leaves the outlet pipe open while he's filling the pool. You know, for me, the outlet pipe was the little plug at the bottom. And so this would be me. We scrubbed out the pool, we rinsed it, we've done all this stuff, we're ready to go. It's a new summer, and nobody plugged the plug. And we've got the hose in it. The hose fills faster than the plug empties, so the water is increasing. But the amount of water all over my yard is also increasing because we're just wasting water here, right? So what are our two workers, or in this case, our worker and our anti-worker? What do we got?
I didn't even type that.
Okay, good. I like that you're using their words, okay? So what's the rate that the inlet pipe actually puts water in, which is what we're hoping to do?
1
Okay, 1/5 of the pool can be filled in what time unit? An hour. Okay? But how fast is the unfiller? It can empty 1/8 of the entire pool in an entire hour. Okay? Now, again, our time units are hours. So, well, let's see. We only really read to the end of this sentence, didn't we? Let's read the next sentence. He remembers to close it after an hour.
So,
how long is that outlet going? 1 hour.
So X plus 1.
Okay, so the inlet goes some more, but it also was going during the 1 hour. Now I'm writing the 1 in front of the X just because that's the order it happened. For 1 hour, they were both open, and then for some more time, this still is pouring in. But I know you probably would rather see it saying X plus 1. Okay, so, but they both had that 1 hour in common. Agreed? And then what do we do with our word problems? Every time, multiply across. So I would put this as 1 plus X, or you have it as X plus 1 probably, over 5. And this guy, oh gosh, 1/8 times 1. No variable there. There's no varying. That pipe was closed in 1 hour. That's not unknown to us. Okay, yeah, just 1/8. So sometimes one of them doesn't even have an X because there's nothing unknown. We knew it all. We know everything that happened to the outlet pipe. We just don't know how long the inlet pipe had to go after Ronaldo finally realized he was wasting a bunch of water. His mom probably screwed him better. All right, so how do we write these equations? And there's something else we have to consider. Are they both adding water?
I wrote it as X plus 1 over 5 minus 1.
Okay. What we should have considered, but I didn't think about it, is this is unworking, so it's working like at a negative rate. That's where we really should have done that, but I was just too busy thinking other stuff. But does that make sense? So if you're losing work, you've got a big old bulldozer digging out a pond and somebody else is dumping shovelfuls in, that's undoing the work. That's a negative rate. So it would be 1 plus X over 5 minus 1/8 equals what every time? 1, because we are trying to fill one whole pool. Now, my advice, and this one, I didn't show you an example the other day, but if you've got these rational equations and you've got a minus between them, it is very helpful to change that to a positive and bring the negative up to the top because you really only keep the tops. Then if you need to distribute, you're distributing the negative with it. So what's your least common denominator here? What's the smallest number of 5 and an 8 both doing? Yes. So there's no, if I were counting by 8s, I'm not going to hit a single number that 5 goes into until I get up to 40. So sometimes you multiply the two together, but not always, so it's worth considering something smaller. All right, so what did I need to multiply the first fraction by so that it would have a 40 on the bottom? Okay, that's going to have to distribute, right? The second fraction needs to multiply by what? Yeah. And the third one isn't a fraction at all, so I'm just multiplying, correct? So new equation looks like 8 plus 8x minus 5 equals 40. Agree? We'll clean that up. What does it look like? 8x equals, hold on. Yes, it does. I'm just looking at last year's note, and I didn't even bother to look down at the next line. Never mind. Okay, doesn't divide nicely, right? So x could be 37/8, but let's consider what question are they asking me before I even decide that's my answer. What question do they ask me? Okay, and in this time slot, where is the more time that's needed after he closes the pipe? Look at everything we have written here. The 1 is pipes open. The x is the more time, so x is the answer. So you could put 37/8 of an hour, but what would you like to write? 5.625. Is there a 5 in front of your decimal in that calculator?
Yeah, but you have to add the 1.
No, you don't, because it says after he closes. So, now, what would the question have said if the 5.625 would have been the answer? Because they could have asked you that. So they might have said, how long did it take for Ronaldo to fill the pool from the time this problem started? That's really not, there's got to be a more efficient way. What is the total amount of time that it took to fill the pool? And then you would need that 1 hour. But they worded it where they excluded the 1 hour. Mom's barking at him. You left the thing running. How long is it going to take you now? All right? As opposed to saying, it took you a total of. See the difference? So watch those words. And that wraps up those word problems. And we zippity-doo-dah right into our 1.7, which is inequalities. Okay, what is it that has you concerned about the inequalities? Oh, she's a hater. Okay, so I'll try to teach you a few things. We're starting off namby-pamby with inequalities that you would see in Algebra 1. And we work up to inequalities that I bet you never saw in Algebra 2. So, the inequalities will take us several days of notes because we're looking at inequalities in all the types of equations we did. Linear inequalities are Algebra 1. But when you start getting into quadratic inequalities and rational, where x is in the denominator, then that's more of an Algebra 2 if you are in an advanced Algebra 2 class that really books their way through the class. So a lot of times, I get students in here that have never seen it, and that's fine. I'll teach it like you have. All right, and then 1.8 is absolute value equations and inequalities together. So we're going to start off with some basic information notes that you need to know about inequalities. General information on inequalities. You're going to want your x to be on the left. Don't say, well, let me put it where it's not negative. No, get the x to the left because then your inequality symbol is telling you which side of that number if it's greater than, it's going to be to the right. If it's less than, it's going to be to the left on the number line, if you did a number line, okay? So, and then there's one little extra thing. You just solve like you're solving an equation, except if you blank or blank by a blank, you have to turn the inequality around. Does that ring a bell?
Multiply or divide?
Multiply or divide by a negative. Then your inequality points the other way. You don't ever change it around if you're adding or subtracting, only if you're at that multiplication and division step, okay? And only if you're multiplying and dividing the whole both sides. So, for number lines, now you've probably done this, you probably did this in Algebra 2 with number lines, okay? And in Algebra 2, your number lines, you probably put open circles and closed circles like that, right? But in college, we tend to find that instead of using open circles and closed circles, they use the same symbols you would use with interval notation. So look up here. If I was making an interval notation, I put a comma where I shade, but an open circle I would use a parentheses, and a closed circle I would use a boxy bracket, correct? Does that sound familiar? Because I don't think we've touched interval notation yet in here, okay? Because it's only used with inequalities. Otherwise, you just have an exact equal answer. So if I were doing a number line, and let's say I solved the problem and the lowest number was a 3 and the highest number was an 8, and I need to shade between, here's what I want it to look like. First of all, most of the time, I'm not going to put my number line on this number line because then it's just stuff on top of stuff, so I usually float it up above. So if I needed to shade between, I would shade between. And let's say that it was going to be an interval where the low number was not included, but the high number was included. Well, back in Algebra 2, you probably would have put an open circle here and a closed circle here. But in college, they tend to say, put the parentheses at this end and the boxy bracket at that end, so it matches your interval notation more closely. Now, that being said, there can be a point on these where I actually use open circles and closed circles, but not right away. It's in a special situation, okay? So that's the format we're going to use. Some of them ask you to give the number line and the interval notation. Some of the problems only ask for the interval notation, but sometimes it very much helps for you to draw a number line so you can see what goes into your interval notation. All right, so that's all we're starting with because we're going right to the book, and the first batch of problems is just like solving linear equations, except they are linear inequalities. So 1.7, inequalities. And I think it's wise for you to put the section number and the title, because these notes are going to probably go with you to college. And it's going to be your Bible. And you're going to look back and go, what did Miss Stewart say about this? Oh, okay, good. All right? So, anyway, the first batch of problems is pretty lengthy. It goes from 13 to 34. These are all linear, meaning I'm not going to see any squares. I'm not going to see x's in the denominator. They are just polynomials. They ask you to do three things here. First, they want you to solve it. And so when you solve it, your answer is going to end up in what's called inequality notation. It's going to have a less than or greater than signs in it. Then they would like you to also write the answer in interval notation, which is the parentheses or the boxy brackets. And if you have a gap, you use the union symbol. Does that sound familiar? Okay. But then they also ask you to graph it. But that's a number line graph, not an XY graph. Okay? So I'm looking for all of that. And we're going to do a few of these, not a ton. Okay? So we are going to start off with, I don't know which one I want to start off with. I'm going to get really out of order here, okay? Because I'd rather you get your feet wet and find out if the water's cold before I just toss you off the diving board into the deep end. Okay? It's been a minute, right? So I'm jumping down to 28, so please remind me that I'm going back up to 18 and 22 after that. Number 28 comes at you like this. There's a -6. It is less than or equal to, and then in the middle you've got 6x plus 3, which is less than or equal to a 21. I like to call these between problems because your x is between your low number and your high number. Now, this is significant, so listen to me. You're going to hear me say, if I was teaching you in Algebra 2, I would have trained my class so that I would say, what is proper between form? And they would say, like robots, low on the left, high on the right, less than, because -6 is lower than all the x possibilities, which are all lower than the 21. So you got to keep an eye on that between form, because as we go through and we get to some other more unusual problems that are not just linear, you're going to have to consider there's between form, and then there's separate form where you work two separate things and it says or. And those are the ones that the graph tend to go out instead of shading between. But if it's between and your x is between, you're
I've
actually...
never ever tried to solve one.
Oh, okay, all right. So instead of me giving you two parts, you've got 3 zones, and you solve all 3 simultaneously. Your goal is to end up with the x isolated in the middle, because your number line is going to be between the 2 numbers that you come up with. So if I didn't have that there, what's the first thing you would do? Okay, well that minus 3 is going to happen in all three zones. But from here on out, you probably can do that without having to write minus 3, minus 3, minus 3, right? Okay, so what would it look like if you subtracted 3 in all three zones? Mm-hmm. Okay, and I didn't do any multiplying or dividing by a negative, so it's still less than, equal, less than, equal. So what's your next step going to be? Okay, you might want to show it here just to help you see how to simplify it. That fraction simplifies on the left. What's it going to be? Over 3 over 2, right? X is alone in the middle. I didn't divide by a negative, did I? It's only if the thing with X was negative, these would have had to switch to greater than. And then 18 divides by 6 really nicely. What's that? Okay. This is the solution in inequality forms because it's got the inequality symbols in it. But they also want it to be on a number line and an interval notation. I find it sometimes easier to go from here to the number line and then go from the number line to the interval notation. Now, you only have two values in calculus. These would be called your critical values. They are critical because out of every number on the entire real number line, there's only two numbers that change you from, in a graph, if it was a two-dimensional graph, your graph would either be going from high to low or from low to high of those points. Okay, so those are the critical values where you can change from positives to negatives. So they're critical. And no other number on the line is really important. All the numbers here in this middle section would give you the same true, false if you plugged them in. So this whole section, if I plugged anything here in for X, it would either make it true or false. It wouldn't be this number would make it true, this number would make it false. This whole section is either right or wrong. This whole section is all right or they're all wrong. Every number out here, either they all work or they don't. So these are the critical values where we have changes between what can happen in the numbers. All right, so the number line, I'd like it to go up above. We had an equal with each one of these, and the X is between. So I'm drawing my line between, and because it was equal, I'm doing what I like to call boxy brackets, because those denote equality. So you okay with my number line here? If I had not had an equal, I would have replaced it with a parentheses. So I only use boxy brackets if I see an equal. So for interval notation, I'm just dropping this down. Oh, apparently I'm starting and stopping with boxy brackets. My X was everything in between the numbers -3/2 and 3. So if you're boxing things or highlighting, all of this answers the three things I was looking for. There's the solution. There's the graph. There's interval notation. So you've not seen them work like this in three zones at once. Okay, I'm glad you're seeing it because that happens a lot. So a lot of times in Algebra 2, they will teach everything as a separate, never as a between. And so then you have to really think, well, which way am I?
Right.
Yeah.
That was the first thing that I thought was between.
Yeah, to me, they should have seen this in Algebra 1 as well. But yeah, we
Yeah,
can't
I've
count
never in
on
my entire life have seen that type of. That,
Okay.
I've seen it as an answer, like I've written my
Okay.
answer that way, but I've never seen that.
So you can work it that way as well, which is going to lead us to more polynomial graphs where things can do many, many different things. So anyway, you may end up with 4 numbers eventually on this number line, and you have like, well, it's coming. So this is building you. But is your mind blown, or are you like, that makes sense? Okay. Okay, not scared yet. All right. So we're going to go back up to catch number 18 now that your feet are a little bit wet. Okay? Number 18 doesn't have 3 zones to it. It only has 2 sides because there's only one inequality. The left side has 6x minus And then in parentheses, 2x plus 3 is a binomial. Then there's a greater than or equal, and the other side says 4x minus 5. Copy it, but don't think about it, because I'm going to go back to here. Just to confirm what all this means. This area that we shaded, I could pick any number in this section between a negative 3 halves and a positive 3, plug it in for x, and this whole thing would end up being true. It's like zeros out there. That's easy to plug in, right? So if I plug 0 in here, this would say negative 6 is less than or equal to 3, agree? And 3 is less than or equal to 21. So let's try something from one of these areas we said doesn't work, like a 4. If we did 6 times 4, what would we get? Plus 3. Negative 6 less than or equal to 27. But that's not less than 21, is it? And if I plugged in a negative 5, what's negative 5 times 6? Negative 30 plus 3 is negative 27. That's not small. No, negative 6 is not smaller. Well, negative 6 is not smaller than negative 27. Yeah, maybe true on this end, but not on this end. Only numbers from here would work. And I included the 3 itself. Let's check it out. What if I plugged in a 3 itself? Which is easier than plugging that in, right? So, what's 6 times 3? Plus 3. Is negative 6 less than or equal to 21? Is 21 less than or equal to 21? So, I included the ends because it said I could. So, whenever you get your solution, you are finding where on the number line you can find stuff that will work. Okay? So, with that in mind, let's try this one out. I will just work it. I will just work it. I'll say another thing. Let's just get this crack-a-lacking. What do we need to do? Do you think we could distribute and combine like terms over here to clean this all up at once? So it's going to be 6x minus 2x, right? Which would be what? And then also what? Oh, did you distribute the negative?
No,
minus 3. Okay, good for you.
I wrote down a figure.
All right. And it says it's greater than or equal to 4x minus 5, correct? And then what would you do?
Subtract the 4x.
What would happen if you subtracted the 4x's? So we are left with the negative 3 because they cancel each other out, right? And we're left with the negative 5. And we know that negative 3 is not equal to negative 5. But because it's an inequality, it could be greater. So look at this. True. If it is true in an inequality situation, or even if this was one of our identity problems and it had turned out true, we would have said all real numbers would have worked. If it is true, there's no number that could cause this not to work. So my number line, well, back to this. If it's true in an inequality, all the real numbers would have worked. As far as my number line goes, how the heck am I going to show that on a number line? It's everything on the number line works. Yeah. So every number works.
So for interval notation, you just put all real numbers?
I would, well, it's since they specify an interval, you would say negative infinity to positive infinity. Just because they specified something different. They're looking for 3 ways of showing it. But if they...
But wouldn't you put
I usually will take either one of these.
Wouldn't you put boxy brackets on it?
Okay, boxies never go with infinities because infinity's not a number that you can reach and say, I have it the biggest number. So boxy brackets only go with an equal, with a, when you have a less than equal or a greater than equal, because there's a number there that you can say, include this number. Well, infinity is not a number. You could start marching towards infinity for the next 47 bazillion years and finally say, I've reached the end. You're lying. You haven't reached the end. So you can't include that number. You can't include infinity because you can't reach infinity. Does that make sense? Okay. So moving on. to number 22. All right, number 22 has a fraction on the, that's not a negative, I'm just making stuff up. Okay, here's what it looks like on the left. In the numerator, we've got a 2x minus 5 over a negative 8, which is less than or equal to, and on the other side, we have a 1 minus x that's not a fraction at all. Oh, this is like very low. Right in. So I am gonna, my plan is I'm gonna observe your honors class.
Okay.
Next week on Thursday, because it's the day that we're bringing food and we have a pep rally that I have to come back for anyway. So I'm just putting in a long day, which means I'm putting in way too many hours. And so I'm taking Tuesday off.
Okay.
So you won't see me on Tuesday, and I will just have you working on whatever you have to work on, because you always have plenty to work on. And so anyhow. Yeah, so that's the day, so I don't know. If it turns out good test, long as we're good in. But, yeah, we'll see where we are. And so if you need a guess, whatever, who knows?
Yes.
So, all right, come on. Okay, so this side is divided by negative 8. This one is not of a fraction. Any thoughts on how you could?
I would multiply those also.
Okay, love it. That would be my best choice too. So, if I am multiplying by a negative on both sides, then this suddenly becomes a greater than or equal to. All right? And this side becomes what?
It does 2x minus 5.
We are free. I'm no longer trapped by that terrible denominator. And over here, hippity hoppity.
8 plus 8x.
Plus an x. Oh, plus an 8x.
Yeah.
Even better. I owe you candy. Just grab it on the way out, okay? All right. So now, at this point, you might want to bring the 2x over so it's not negative, but you need your x on the left because it will be pointing the right direction that your number line should point. So bring it over, and you get a negative 6x. Greater than or equal to negative 3, which means now you have to divide by a negative, and you flip it back. Okay, so we have an x less than or equal to, and be careful and don't tell me the answer is 2.
Oh no, that's right.
So what's your answer?
That's 1 over 3, right? 2.
1 over 2. So if you know the fraction needs to reduce, I think it may be best for you to actually look at the fraction, write it on the paper before you simplify it, okay? So now, in this case, there's only one critical value, isn't there? This critical value here splits my number line into everything to the left of 1/2 and everything to the right of 1/2. So I only either shade to the left or shade to the right, and because we got x in the front, this tells me which way to go. So all the numbers less than 1/2 would make this true, but also 1/2 itself would make it true, wouldn't it? So watch what I'm going to do.
Bracket, right?
Gobbling up the line that you drew. So that means if you have an arrow going out forever, you've either gone towards negative infinity in this case, or you went towards positive infinity. And if you went towards negative infinity, this is your high number.
I'm going to warn you now. I'm trying to look at my infinity sign for my answers. It's going to be right.
Okay, so do you turn your paper
Yes.
to write an 8 every? Have you ever tried Harry Potter glasses so you don't have to turn your paper?
Yes, and it still looks crazy.
Okay, that's all right.
If I draw it like that, it just looks like bubbles.
Big old googly eyes.
Yeah.
All right, so we've kind of gotten our feet a little bit wet now, right? New concept of, okay, we got about 5 minutes. Let's keep going. All right, the next one's a between again. All right. So number 34. Can I even put it where you can see it? No, probably not. All right. 1 is less than or equal to The middle has 5x, I lied, 4x minus 5 over a negative 2, which is less than a 9. So I only have the equal on the left side, not the right side. So what would you do first?
Multiply by negative 2.
And what's that going to do?
Negative 2 greater than or equal to negative 8x. Nope, that's the same. 4x. 4x minus 5 greater than negative 18.
Ooh, yeah. Okay. Can I say that? No, I really can't say it. All right. You could pick the whole thing up and turn it around, but let's just go ahead and finish it off before we bother. Okay? So what's the next thing you need to get rid of? Everywhere, right? So what would this end be?
Positive 3.
Okay. Greater than or equal to 4x, which is greater than...
Negative 13.
Okay. So we definitely don't have the low number on the left and the high number on the right. But we also don't say less than either. Then we're going to divide by 4. None of it wants to divide nicely by 4, does it? Okay. So, at this point, I would pick the whole thing up and reverse it so that negative 13/4 is on the left. So that becomes a less than. X is in the middle. Less than equal 3/4. Are you okay with what I just did? Okay, good. Box that because that's your inequality. And then how many tick marks does my number line have? I have how many critical values? 2 of them. And on a number line, it's always low on the left, higher on the right, because number lines go numerically. That's what they call number lines. And X falls between, right? So, what would I put above the negative 13/4? Okay, and over here. And then your interval notation has practically written itself now. So, the interval goes from negative 13/4 exclusive, meaning you couldn't plug in a negative 13/4 and make it true, but 3/4 could be plugged in and would make this inequality true. Okay? So, that takes care of the linear ones. So, the next batch of problems is 39 through 48, and it's your quadratic inequalities. And with quadratics, according to the fundamental theorem of algebra, there's 2 possible solutions, right? But with inequalities, there's infinite possible solutions. So I have a whole little list of to-dos for quadratic inequalities, which we might have time to glance at the list before that bell rings, okay? And then we'll probably glance at it again on Monday because I'm going to put my start here, right there on that list. So, ways to set it up. Set it to 0. Make sure the 0's on the right side, which I don't have to worry about because you like to do that anyway, naturally, right? So.
If I set to 0, what do you mean if there's something between?
There won't be a between.
There won't be a
Okay, not going to be a between here. Now, a between may create itself in the process, but it won't start off. So it's going to be ax squared plus bx plus c greater than or equal to or less than equal to 0. All right. Now, sometimes they don't have the whole trinomial. They may not have a linear time. They may not have a constant. But you want to set the quadratic with 0 on the right. Okay? Now, this is important. If it says greater than 0 then, or greater than equal to 0, tell me a number that's greater than 0.
4.
Okay? Or 84 million.
Yeah.
All the positive numbers are greater than 0. So if it's greater than, it means you're looking for positive values. And we're going to do something that's called a sign chart. And I don't know if you've ever seen this before. Okay? So we will just start right here on Monday. Okie dokie? All right. So in the meantime, you gotta get back from work, 1.6 finished by Monday. And you keep working. We're learning a little bit more on your test review. But you might start in on trying some of those odd problems on 1.7. But don't start on the quadratics because just don't even try stuff to stick in your head first. Right? Okay. Good morning, Elise. Grab a Chromebook and yeah, probably calculator too. And go ahead and good job. Bust out your composition book so you can do some scratch work there.